Okay, I should be up and running. It's our first homework of the semester, and hopefully giving you a few things you've seen before and a few things you may not have, just to get us started. Not to scare you too much with just about how much I'm going to throw stuff at you in the first couple of weeks here, because I am going to overload you. But remember, you got until midterm to get a grade. We're looking for your best test score. So you got to stick with problems, and there's no way you can learn how to do a problem unless we start a conversation. So we're going to start a lot of conversations. And I think we mentioned, hopefully, this is something that was mentioned today in class, that the letter X is Arabic and means the word something. So if I were to write 2x plus 5, 2 times something plus 5 equals 17, think about the problem that way. All right, so we introduce functional notation, hopefully. Hopefully we had enough time to do that. And so this notation is very similar to saying, okay, I'm going to change this. I think I got a worksheet that had a minus on it. I'm going to change it to a plus for you. And let's talk about this function. All right, and we're going to evaluate. Evaluate means to plug a number in. And we're going to plug the number 3 in. Then we're going to plug the number 28 and the number 103. And we can talk about why I'm picking those numbers. But what's the square root? Well, geometrically, we want to know how to draw a square root. And I don't think you've probably drawn these things too often. Why do we start with a square? And so what's the square root? It's the side of the square. Right? 9. What's the square root of 9? 3. It's that distance. Okay, so we're starting with an area statement. Starting with the area, and we're talking about the dimension of the geometric shape we've just drawn. So I picked some numbers for a particular reason. I picked 3 because 3 minus 3 is 0. And if I have 0, I guess that means that the area of this square is disappearing right before your eyes. And what's happening to the side length of the square as I make that area smaller and smaller and more smaller? It's tending towards 0. So does the square root of 0 exist? Only exists if something times something. I don't know why I have 2 squares, but something times something gets us 0. Then yeah, 0 times 0 gets us 0. So the square root of 0 is something that we can do. It's permitted. And so we'll call this 3, 0 here because I picked some really big numbers. So that's now 3 units from there to there. What happens when I put 28 in? Well, you stop the video and you see if you can do the calculation. I'm picking it because I think that I'm calling this a user-friendly number. What do I mean by user-friendly? I don't need a calculator for this. 28 minus 3, square root of 25. What's the square root of 25? 5. We're going to multiply that times 2. That gets us 10. What are we going to do with 10? We're going to have 4. And we get 14. So if that's 3, about 10 times that to get to 28, which is about here. So here's 28 out here. And we just got 14 units. Why don't we call this 14 units up here? And so that's another point. And when we get that kind of trajectory, I picked 103, which is off the charts. I think I'll change that right now to something that you can see maybe more clearly. Why don't we pick 19? You can see why I might want to pick 19. 19 minus 3 is 16. Square root of 16 is 4. 2 times 4 is 8. 8 plus 4 is 12. Now, where is 19 in relationship to 28? Well, there's 25 units of change here. 19, 16, and from 19 to 8 to 28 is 9. So 6, I think I'm probably here. In that vicinity would be the number 19. And if this is 14, then 12 might be there. So I might even be a little higher than what I originally drew. All right? So I hope you can see the bend, the arc, right? And I had picked 103. Hope you can see how that's user-friendly. So that would get us 24. 103 gets us 24. So I hope you can see this concave down shape. Concave down, that's concave up, concave down. terms I'll be using during the course of the semester and talking about conceptually what it means, what a concave down shape is telling us about some correspondence out there in the real world, right? Because we're going to use math to figure out things outside these halls. All right. But can't use it until we learn mechanically how to work with it. All right, so did I draw the square over here? And I forgot, so square root is a distance, geometric interpretation. And so the square root starts with area. So really it's an area statement that we're looking at. And it looks like it's initially going up very quickly, but over time, rate of change takes more and more. You know, you got square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, square root of 16 is 4. And if you're looking for patterns, I think you got one here, change of 3, change of 5, change of 7. Right? It's taking a little bit larger area to go up by 1 each time. And that is just going to continue until some of those numbers get really big. All right, so what's the easiest way to do this calculation? You can do calculations many different ways. I think I immediately see 17 plus 3 is 20. And if I put 20 with minus 29, I get minus 9, minus 15, minus 9 is the same thing as the opposite of 15 plus 3. All right, so minus 24. You should have already learned that in your pre-algebra classes, hopefully elementary school as well. So we talked about what this command means today in class. Do you remember? Can't do the problem unless you know what it's asking you to do. Okay, so this is all about finding values of exponents. Logarithms are exponential values. So we're trying to look at the exponential value you put on top of 3, you get 27. Okay, and we could have done 0 and -1. I haven't talked about these exponents yet, but I think you can probably see what they are, at least numerically. I'm not going to explain. I'll do zeros and 1 negatives tomorrow in class. We'll get up and running with those. But, you know, what am I doing here? Multiplying by 3. So if I wanted to go in the other direction, I guess I'd divide by 3. So 3 to the 0 is going to get you 1. Divide by 3, 3 to the -1 is going to get you 1/3. And this is asking what exponent gets us 27. So once, twice, I guess I got to do it 3 times. Okay. And if I wanted to express 27, I could say it's 3 raised to the 3. It's your 27. Okay, enough on that. What's another way we can write this product? Well, we can write it as an addition statement. Why is it here? Because I want you to be able to verify that that is true. Not a formal verification, but you remember from class today what algebra is about? True for all numbers? Well, pick a number. See if it's true. Why don't I pick 10? 10 minus 5 is 5. 5 times 3 is 15. 10. 3 times 10 is 30. 30 minus 15. Check. Try another number. Get in the habit of trying numbers and checking your work. All right, we can do that here now. What is x plus 2 times x plus 5? It's a rectangle. Most of high school math is all about rectangles. X plus 2 times x plus 5 is length times the width. And I'll show you why it's x squared plus 7x plus 10. And you take a moment to look at the 7 and the 10 and figure out what you might be doing here and why. So x is some distance. Let's just call it that. There's an x. Let's go down 2 units. We'll keep them small. So that's 2 units. Let's go over 5 units. 1, 2, 3, 4, 5. And let's add 5 and let's find out the parts of this area. And to do that, see, I got the eraser here. Can I get the eraser out of my pocket? It fell out of my pocket. Here we go. I don't want it to be shabby here. Here we go. All right, so what do we get? Oh, we get x squared. And then we have some units here. 1, 2, 3, 4, 5. Let's erase this too. So there's 5 units. And then we have 2 units. I'll keep them about the same width. Try to 1, 2. And then it sure looks like we've got 10 little boxes. We have 1 times x, another x, another x, another x. We have 5 of them. Well, I guess I just did 4. No, I did 5. And then we got 2 of them right here. And I think we discussed like terms in class today. I'm sure we must have. So it seems to me that another name for x plus 2 times x plus 5 is x squared plus 7x plus 10. I may write this product as that sum. How do we check it? Yep, you're right. Pick a number. Now, what would be the easiest number to pick here? Probably the number 1. 1 plus 2 is 3. 1 plus 5 is 6. 3 times 6 is 18. If I put the number 1 in here, I better get 18. 1 times 1 is 1. 7 times 1 is 7. Plus 10. I got it. I think I can move along. All right, got another function, different calculation, so we give it a different letter. G of -5, no reason to talk much about this. 2 times -5 cubed minus 5 times -5 plus 1. I'm just checking your work with negative numbers. Trying to get a sense of what your skill level is as you come into the class. Okay? Negative number is an opposite symbol. So if I'm walking to the right and I put a negative in front of it, then I'm walking to the left. Well, that's left or right on your screen. But if I'm moving up, 5, I put a negative in front of it means I'm going down 5. And every negative is a change in direction. And so I've got 3 negatives. So -5 times -5. Okay, so I'm on the number line at -5. -5 times -5 times -5. Okay. Negative times a negative is a positive, times a negative is a negative. So this gives me 2 times -125. A negative times a negative is a positive. And I hope that you get -250 plus 26. Negative is going to win out. So this is the same thing as the opposite of 250 minus 26. So take away 20, 230, take away another 6, 24. So we have -220. Right? And if you got that wrong, you're going to have to really bear down in class to watch your negative signs because that can cause trouble throughout the entire semester. So you're going to have to really think about what I just said. When you multiply by negatives, basically the pattern is if it's odd multiplication of negative numbers, you're going to get a negative answer. And if it's an even, because -5 times -5, -5 in parentheses squared, which does not equal -5 squared, by the way, does not equal that. But if you said 7 minus 5 squared, there's what I wrote. I think you'd probably write -25 from class today. Do you know why? Because squaring is a more difficult operation than subtraction. The order of operations are hard to easy when we evaluate. Well, grouping symbols first. All right. So I guess we're done with that. I've got to change what I wrote on your worksheet. So very important that you understand how to work with fractions. So we'll be doing a particular problem soon every day to make sure you can multiply, divide, add, and subtract fractions with ease. All right, so let's look at 6/2 times 4 just one more time. I hope we can see that 6/2 is 3. And 3 times 4, we know the answer is 12. So when I do this, I have to get 12. I know 6 4s are 24. And I think I got to divide by 2 to get 12. Okay, so multiply and then divide. That's what we're doing. This is actually over 1. And 6/2 times 4/1, multiplication is commutative. So this could have been written as 6 times 4, but I'll move the 1 over here and the 2 over here. Now, what would you do first? I would hope you do 2 into 4 twice, and 2 times 6 is 12. And you might say, well, why am I showing you this? Because I know that some folks don't know it. And the other is the conversion process is based on operational division. And if you're going to see the operational division conceptually, you have to know that the order you do this in doesn't matter. I could divide 2 into 6, then multiply by 4. I could multiply 6 times 4 and then divide by 2. Or I could divide 4 by 2 and then multiply by 6. And that's the one that I want you to be able to see. Because when we start writing linear, quadratic, all these different conversion calculations, it's seeing the operational division that's going to allow you to see some easy numbers. All right, so number 9, still talking about this and that. Okay, I guess you can see that. Let's push this up a little bit. All right, so we're just going to look at continuing the pattern, and these are called sequences. I added one more problem that we didn't do in class. Maybe we will get to it because I haven't handed anything out yet. This is still a few days before our first class, so maybe I did talk about problem 11 here. Momentarily, we'll get there. All right, so what do I see on the right side? Hope you see a pattern here. Hope you see that. What do I see on the left side? Hmm, 19 and adding 5, sorry. Okay, we're going to talk about that term, that x and y value in a moment. And so we're just hoping that you've got the pre-algebra skills to plot. You can think of this as horizontal movement, and that is vertical. So the first thing we do is we move horizontally 4 units. I'll call that 4 units down 7, and that's the coordinate for -7. And I think I should put that on the other side because we got a decreasing function. No, I'm on the correct side. No, I'd rather be over on the side. Or -7. Okay. 9, -10. Well, 9 is 5 units further to the right. So if that's 4, that's about 5, I guess, somewhere in here. So I'm moving 5 into the horizontal, and then I'm going down 3. Going down 3, something like that, maybe. And all you need is 2 points to draw the equation line. And so that's the discussion we want to start with. And so what is this coordinate? The 9, -10 looks to be in the right position, right? And all of these will line up. Over 5, down 3. Over 10, down 6. All right, so this is actually called a sequence. Right? -7, -10, -13. And if I wanted the 5th term, I think we know it. Right? It's -16 is the 4th, -19. Right? But we're going to have sequences that have a lot more numbers in them. And we're not going to count by hand like that. But if this is your first term, -7, how do you get to -19? Well, it looks like you got to figure out what's called the common difference. And the common difference is -3 times, how many times did I do it? 1, 2, 3, 4, which is the 5th term, right? If I'm looking for, that's how it's usually written in the textbooks. If I'm looking for the 5th term, then I'm starting with the 1st term, and I'm using that common difference times the number of terms -1, because that's my 1st term. But when you count, remember, when we count, we usually start from 0. We're starting from our 1st term. So to get to the number 3, for instance, I only have to go up twice to get to the 3rd term. Right? So it's always 1 less. And I'm giving you that because it's on your SATs and it seems appropriate. It just seems appropriate to talk about it right now. Start the conversation. Okay, so now let's write the equation of a line. -4, 15, 11, -2. Well, what did we talk about in class? Subtraction and then operational division. Those are things that can cancel the this is to give us the that's. So subtraction, I have to subtract the first term. What's the first term? It's -4. Well, that obviously becomes x plus 4. And when I put -4 in, -4 plus 4 is 0. And if I multiply 0 times something, I don't need a calculator. And what did I want to get for an answer? 15. I got a marker, very empowering. So I'm starting with x's and I'm getting y's, and textbooks don't put the y on the right. I wish it would. Then we've got a left to right orientation. Okay? But your textbooks put it here. It's the evolution of the discipline. We're not going to change every textbook in the world, that's for darn sure. All right, so that gets us started. We're halfway there. We just have to make the next coordinate work. And I don't know about you, but the only way I get -2 is to have -17 plus 15. This whole thing here has to equal -17 plus 15. Right, now, what do I get when I put the second x value, 11? 11 plus 4 is 15. I don't want that 15. So I'm going to write it here, but remember, it could have been written here. It could have been written there. Keep that in mind. You might be able to see the conversion process with all of these calculations. Now, I'm sorry that I had something that shows up twice. Do not like that. So I'm going to change this again because I haven't given you the printout yet for what we're working on. So I'm going to make another change here. I'm going to make this -4. Okay, so that we get some different numbers here. So let's start with y equals. Repetition's our friend. You know what to start with? I hope you say x plus 4. Gets rid of -4. Adding 4 to -4 makes a 0. And I want 15. Well, that x value gives me that y value. Now, when I drop an 11 in, I get 15. Ah, that's not the number I wanted to change. Idiot. All right, so I can do it again here. I wanted to change this side. This is fine. That's fine. So -4, let's go to 7. All right, so how do I get from -4 to 7? Change by 11. Okay, there. Every number is different. So hopefully you can see what goes where. A little easier. Nobody in my classes since 1993 has ever gotten this problem wrong on a final exam. And one student last year who I wasn't convinced was going to get this each and every time. But other than that, since 1993, nobody gets this wrong. So if you're worried about it, don't. This is a marathon. You got 2 months before midterm. And if you do this every day for a minute, students, the first day or two, struggle a little bit. By day 4, usually folks are writing it at 30 seconds. And by day after midterm sometime, it's a 5-second problem. Okay? So that's what's going to happen. And it connects some neurons, takes time. You got to learn to just, put your hand on your chin and go, oh, yeah, okay, let me think about that. Because we're going to talk about it again tomorrow. And in class, if I see you struggling with something, I'll give you another problem like it. And 20 minutes later, give you another one. Give you a chance to forget, and then try to get that long-term memory to get mechanically what's happening. And what's happening from 15 to -4? I think I'm going down 19. Yeah, on a number line, to get from 15, I got to pass 0. And I got to get to -4. I think I'm moving in that direction. So I'll let you know that. All right, and that's that equation. Now, solving equations. If evaluating is hard to easy, let's see if I can move this table back a little bit more. Think of evaluating as finding your way to some place in the forest. Okay, and you go to the oak tree, you take a right, you see the big rock, you step on it, you jump off, and you run. Then you get to the spot you want. Well, what if we knew we were at the spot we wanted to be at, but we didn't know where we started from? Well, you got to come back, you got to jump backwards onto the rock. Instead of taking a left, you got to take a right, and then you got to walk backwards. And I hope you get my drift, because I'm not going to say that again, because I think I'm lost in the woods. All right, so What's the first thing Aunt Sally would tell us? Parentheses. Very good, Aunt Sally. And then she'd tell us multiplication and division. Could be division or multiplication. The only poor thing about Aunt Sally is she didn't go past, I guess, her multiplication and division, because she didn't talk about powers and roots, and she didn't talk about exponents and logs, and she didn't talk about sinusoids and inverse sinusoids. She didn't talk about integration and differentiation. I mean, this keeps going on and on and on. So basically, evaluation is hard to easy. So what is solving? Easy to hard. What's the easiest thing over here? Subtraction of 3. I hope we can see that something minus 3 equals negative 17. And that something better be negative 14. And this whole thing has to be negative 14. It's the only way that's going to be true. So what would you do? And I don't want you showing every step. Oh, drop that on the floor. I got to reset right away. I'll come back and do a better job later. In this class, I'm going to break every rule you ever heard. I don't want you showing me every step. I want you to look at this and go, I'm going to add 3. Instead of division, I'm going to multiply. Minus 70. We all make mistakes, and instead of multiplying by negative 70, by negative 7, I'm going to divide by negative 7, which gives me 10. And instead of adding 2, I'm going to subtract 2, and I think 8 is the number that if I had a table of values, I had minus 7/5 x plus 2 minus 3, then I think I get negative 17 when I plug in an 8. Let's find out. 8 plus 2 is 10. Oh, yeah. So what did we say we could do with that? We could take this 5 and move it into that position. That's what I want you to be able to see, because we're going to be learning how to find user-friendly numbers in this parentheses so we can get quick information, not have to work so hard to understand what we're looking at. We're going to do that by doing these problems every day. Every one of these problems can be on every test by midterm. You know, your first test can have every one of these problems and probably another 5 times the number we're looking at right now. So we just got to get a lot of practice. So 10 divided by 5 is 2. 2 times negative 7. Oh, there's my minus 14 minus 3. We're good. Okay? And first thing you do is come in tomorrow in class, and I'm going to hand you one of these worksheets, and you're going right to the board. And then, after we get moving on that, probably going to really start hitting you with some new material. All right, so we are going to be learning a templative graphing process, and I'm not going to find it in the textbooks, but it simplifies things and it makes things really easy once you get the hang of it. So you're pausing the video. I'm just going to write the answers. Linear function through the points 8, 5, 11, 7. I hope you might have come up with x minus 8 gets rid of x1. I want y1 plus 5. 8 to 11 is a change of 3. And when I put 11 in, I get the 3's to cancel. And 1 plus 5 is 7 is 2. So there's your linear. Put it over here so you can see just how closely aligned all of these calculations are. And they're all based on the principles of working with zeros and ones. Absolute value. Right? Well, what happens with absolute value? Absolute value measures distance from 0. Well, if I go I've gone a distance, which is positive. And if I go backwards, I'm also moving a positive distance. You know, if I take 2 steps this way, that distance is the same as taking 2 steps this way. I hope it's the same. Help my golf game if it's the same. Nothing's going to help my golf game anymore. Anyway, so think about x minus 8. What happens when you put a number 9 in x minus 8? You get a positive 1. What happens when you put a 7 in for x minus 8? You get a negative 1. What happens when I slap it with an absolute value? Still get positive 1. But I don't get negative 1 anymore because the absolute value of negative 1 is a positive 1. So I get a sign change. Right? So what does this graph look like? Looks like a V shape. I'll prove that to you in a minute. And the calculation is simply 2/3 absolute value of x minus 8 plus 5. Boy, it doesn't look much different. Now, I'm going to put this to the first power because the number 3 is really 11 minus 8 to the first power. And this 3 is really the absolute value of 11 minus 8. That's what's really being canceled here. All right. Okay, that's should be spread out a little bit more, but hopefully you can follow what I'm doing here. Let's move these down a little bit. It's a quadratic, give it a little more space. Square root. Let's give that a little more space. All right, so the next one, quadratic. Well, first off, this is 8, 5, the vertex. We call this a vertex. It's the most important point on that graph. And we also know that 11, 7, we'll call this 11, 7. Anybody tell me what this coordinate is? Oh, it said 5, 7. Right, because it's the same height, right? 7, same height on a graph. And if I went 3 to the right, 3 to the left is going to give me the same answer because absolute value is measuring distance. So let's put 5 in and see if it works. 5 minus 8, the absolute value of negative 3. 2 times 3 times the absolute value of negative 3 plus 5. I hope you can see that that cancels because the absolute value of negative 3 is the same as positive 3. I can move that 3 right there. I can see that I've created the number 1. Multiplying times 1 is easy to do. It's only one multiplication easier. That's right, multiplying by 0. So what's the quadratic? Quadratic is x minus 8 squared, very similar to the absolute value. Quadratic is going to get us a U-shaped graph, and we'll have to, graph y equals x squared in class. Start talking about it. I should have a board where I can turn it around and you can see some of the user-friendly numbers. But we're getting up and running, and Rome wasn't built in a day. So what goes with an 8? A 5. Just like the absolute value, we have a vertex, minimum value of 5. Never going to get anything smaller than a 5 out of this calculation because squaring numbers produces positive results, except for one square. There's one square that you square the square root that doesn't give you a positive. That's right, 0. Okay. So now what happens when I put an 11 in? Well, when I put an 11 in, I've created 11 minus 8 squared. Go figure, it's not in the textbooks, but that's what it is. And so how do I get from 5 to 7? Still go up 2. So let's see if I can move this linear. 2/3, x minus 5, x minus 8, sorry. X minus 8 plus 5. That's the linear. That's 3. Square root of 11 minus 8 is a 3. 11 minus 8 squared is 9. 9 units of change. And 9 units of change plus 5 does not bring me to 7. So I don't want that 9 units of change. I want 2 plus 5 because that brings me to my y value of 7. What's the square root? Pause the video, see if you can come up with it. What's the square root? Square root is 3 squared. Square root is 2 over the square root of 3. Square root of x minus 8 plus 5. Right? I'm sure you don't have a good feel for these calculations yet in terms of graphing and understanding why they work. That's why we're starting the conversations early, so we can have them for a long time, so that you will figure out what you're looking at before midterm and the end of the semester. All right, so hopefully, even if you don't have a clue what's going on, write those answers down on your answer sheet so I know you at least looked at the video and at least tried those problems. We're going to pick up the pace tomorrow and let you work at whatever pace is comfortable for you. Take your time at the board. If you like to push on through and get lots of looks, that's, I think, great. But we'll start working a little more earnestly tomorrow. You won't be listening to me talk so much at the start of class because we already got a conversation going on a lot of problems. But halfway through the class, I think we'll probably sit down, put a few more things in your mind. All right, see you tomorrow.